This is a Tesla driving itself through a city. No LiDAR, no radar, no ultrasonic sensors, just 8 cameras and a neural network. And since 2024, there isn't a single line of code inside it that says this is a roundabout. Nobody wrote it the rules of the road. It learned to drive by watching people. So how does a car actually drive on cameras alone? Let's strip away the hype, how it sees, how it learns, and where, honestly, it still falls short. The bet was made in public. April 2019, Tesla's Autonomy Day. While the rest of the industry was piling on LiDAR and radar, Tesla went the opposite way. Elon Musk called LiDAR a fool's errand. Andrej Karpathy, then Tesla's head of AI, called it a crutch. Their argument? The whole road system was built for one sensor, the human eye. It was a bold thesis and a contested one. Plenty of self-driving engineers thought it was reckless. Hold on to that tension. This is Tesla's argument, not settled science. And they didn't just talk. In May 2021, Tesla deleted the forward radar from new cars. Late 2022, the ultrasonic sensors went too. They called it Tesla Vision. Why remove sensors that worked? Karpathy's answer. Once the cameras get good enough, a low resolution radar stops helping. When the two disagree, it just adds noise, and something has to decide which one to believe. He showed exactly where radar failed. It lost cars braking hard ahead, it slammed the brakes under harmless bridges, and it stared right past a stopped truck. Fusing that in was a liability. But can you really get distance and speed from flat pictures? Tesla's answer was an unequivocal yes. The same way your brain does, by training neural networks to read depth straight out of the pixels. Now the honest counterpoint. Rivals like Waymo keep LiDAR for redundancy, a second independent way to see. One camera blinded by sun, fog, or glare has no backup. That risk is real, and the debate is not settled. And the switch had a cost. After radar was dropped, drivers reported sudden phantom braking for no reason. It drew a 4-year federal probe, closed in 2026 with no recall, but tied right back to that radar to vision change. So, if it's all cameras, how does the car turn 8 video streams into an understanding of the world? That took 3 big ideas, each built on the last. First, the HydraNet. One shared vision backbone looks at each camera, then splits into dozens of heads. One finds cars, one reads traffic lights, one traces lanes. One body, many heads. It was efficient, one pass, every task. But each camera still saw the world on its own in flat 2D. To actually drive, those 8 views have to become one. So in 2021 came the second idea, a transformer that fuses all 8 cameras into a single bird's eye view. One top-down map of everything around the car. 8 perspectives, one world. They also gave it a memory. When a car slips behind a truck, it doesn't blink out of existence. A short-term memory holds it in place until it comes back into view. The third idea is the clever one. Instead of naming every object, the occupancy network fills the world with tiny 3D cubes and asks each one a single question. Is this space full or empty? And where is it moving? Why that matters? It can stop for anything. A fallen ladder, an overturned trailer, a shape it has never seen, without ever needing to know what it is. That's what replaced the ultrasonic sensors. Now the car can see. But for years, the part that decided what to do, the planner, was still 300,000 lines of handwritten rules. If roundabout, then a rule book for a world that breaks every rule. Then in 2024, FSD version 12 deleted almost all of it. The rulebook was replaced by a single neural network trained on human driving. Musk's phrase for it: photons in, controls out. One honest caveat: end to end is partly marketing. It isn't one giant brain. Perception and planning are still separate networks. What truly changed is that the driving decisions are now learned, not scripted. So, how do you teach a car to drive by example? The backbone is imitation learning. Tesla grades human drivers, keeps only the best, and trains the network to copy them across millions of real flips. Here's what most people get wrong: this is not mainly reinforcement learning. Reward and trial only became a real training stage in late 2025, and even now it's a finishing touch, cleaning up the rare, dangerous cases imitation misses. And the newest twist: Tesla now runs some of that trial and error inside a learned world simulator, a model that dreams up driving scenes to practice in. Promising, but still the newest, smallest piece of the puzzle. But the real engine behind all of this isn't any single network. It's a loop, one that turns a fleet of millions of cars into a teacher that never sleeps. It begins in shadow mode. A new network runs silently inside customer cars, predicting but not driving. Whenever its guess disagrees with what actually happened, that moment is worth saving. The fleet is far too big to upload everything, so Tesla writes triggers, little detectors for the interesting stuff, a canoe on a roof, a tunnel mouth, radar and vision disagreeing. In 2021, they had 221 of them, hunting the rare long tail. The clips come back and get labeled, mostly by machines. By replaying many trips through the same street, Tesla rebuilds the scene in 3D and auto-labels it, even in rain or darkness. It claims 5 million hours of human labeling done in about 12. And that closes the loop. Every disengagement, every near miss becomes tomorrow's training data. The car's worst moments are exactly what make the next version better. And no, it isn't magic with zero people. A large team still grades drivers, curates the hardest cases, and checks the machine's work. The auto labeler handles the bulk. Humans handle the judgment. What about made-up data? Tesla does build simulations, but here's the second thing people overstate. Synthetic scenes are a supplement, not the main diet. Real fleet video is the substrate. Simulation earns its keep on the scenes too rare or too dangerous to catch for real, like a moose loose on the highway. In a sim, every label is perfect and free, and no one gets hurt rehearsing the nightmare cases. And by 2025, the simulator itself became a neural network, one that can generate driving worlds you steer through, inject a sudden hazard, or replay a failure on demand. The same brain, Tesla says, will teach its Optimus robot to move. So where does that leave things today? At staggering scale. By May 2026, the fleet had driven over 10 billion supervised FSD miles, and it's adding roughly 29 million more every single day. Musk's threshold for truly driverless cars is around 10 billion real miles, which is why robotaxis are the North Star. And remarkably, the very same AI is being reused to teach Tesla's humanoid robot how to walk. But keep the hype in check. This is still supervised self-driving. The human is legally responsible and must be ready to grab the wheel. 10 billion miles is not the same as proven driverless safety. And a lot stays behind the curtain. Tesla has never published how much is imitation versus reinforcement, how much is real versus simulated, or whether the camera only bet holds forever. There's quietly been radar hardware on some cars since 2023. So the real story was never cameras versus LiDAR or some AI miracle. It's a self-reinforcing loop, a fleet of millions, quietly turning every mistake into a lesson, one edge case at a time. The machinery is remarkable, the scale is staggering, and the finish line is still ahead. Thanks for watching.